You to YouTube channel of Gradeup. I welcome all of you to YouTube channel of Gradeup, and today's session is about strength of material. Now it is a BARC booster, and we are now going to solve few very fantastic questions on strength of material. So all of you please join together. Please join together as quick as possible. And those who are here, please let me know whether I am audible or not. Am I audible to all of you? Okay. Hello, Atulya. Good afternoon. Hello, Shubham. Hello, Asif. Okay. So share it. Good afternoon, Swamijit. Share it and quickly we will start our session. The number of questions are quite more, so we need to be little bit faster here, isn't it? Okay. So it will be very much beneficial. See, a lot of questions are coming from the strength of material chapter, and if you are solving it, if you have a practice, you know, you don't have much time, enough time. Okay, you're talking about engineering services prelims, right? Yes, that generally it happens. It happens. So no need to worry. No need to worry. Yes, it is for civil engineering branch, of course, Asif. It is for civil engineering only. This is my kind request. Please, all of you share it, and like it. Okay, let us start now. This small introduction of mine, and my Telegram channel link will be given in the chat box. You can simply go to the chat box. At top of the chat box, you will get the link for the Telegram channel. There are batches going on for Vision 2022 and 23. Both are going on. If you are interested, can join and get the subscription of that. There are mega mock challenge going on 14th and 29th August. You can sit for the gate and BARC examination. Now let us start the session. In a mild steel specimen subjected to tensile test cycle, the elastic limit in tension is raised and the elastic limit in compression is lowered. This is called as. Okay, you please share the link. I will wait. Yes, why not? Mechanical too can join. Okay. Okay, please do share the link, all of you. So here it is your Bossinger effect that you know very quite obvious. Cyclic load, actually sometimes students see that cyclic load. No, they used to think about only fatigue. It is not fatigue, it is your Bossinger effect. When the yield value will come down, when the yield value will get changed due to the stress reversal, that effect we are calling it as Bossinger effect, isn't it? Which stress is considered for the design purpose of the mild steel? Which one is correct here? Which stress is considered for the design purpose of mild steel? which stress is considered for the design purpose of mild steel. Okay, nice. So here the lower yield point has to be considered, isn't it? Lower yield has been considered for the design purpose in the mild steel. Upper yield, and then you have lower yield, then you have a plastic, then you have strain hardening, then necking. You all know that strain hardening, then necking, then the plastic zone, then yield point. So that upper and lower yield, 2 points you have here. Lower yield point will be considered for the designing purpose. Absolutely correct. Find the total deflection here. How you will calculate the total deflection? That is once again the step bar problem. See, whatever the problem you will get for the step bar, what I told you, simply you have to go for simple approach. Whether it's a cantilever or whatever it is, always try to draw the free body diagram. Now you have a three component, three block with a different cross sectional area, isn't it? So for all the three block, if you'll that cross sectional area has been already given. If you'll draw the free body diagram, what you get exactly here, isn't it? So stand at the central position for the larger block, and if you see that, you have to see either one side, either this side or that side. You don't have to go anywhere else. Either you see towards right side or left side. If the whole structure is under static equilibrium, the piece, whatever the block you are taking out for the free body diagram, that also will be under static equilibrium, isn't it? So no need to worry, add only one side of the forces. So it is under compression of the 2p if you'll see only one side. So the larger block, if I draw, it is under compression. Now other side you don't have to worry. Simply apply the one side, and other side it has to be simply that way, isn't it? So deformation, yes, PL by AE. So calculate that delta will be what? Delta 1 is supposed, that is 2P, so 2PL by AE. 2P and L is L only, I think. 2PL by AE. What is that A? 3AE. Now what is for the middle one? Stand at the central position and add either right side or left side. I'm adding all the right side forces. I can see only one force, that is 2P, is acting on this block. So the smaller block also has a 2P which is acting this side. Another side, I will not at all worry about anything. I will simply apply without any hesitation. If 2P I can see, if I'll see towards this side, other side also it must be 2P. It must be 2P in opposite direction, so that it will be under static equilibrium. It must be. Then for the third one also, I'll go to the center line and then I'll draw the free body diagram. See, I'm explaining it. That's why it is taking time. Otherwise, within 45 seconds you can solve it. Within 45 seconds or 50 seconds one can solve this. So if you're standing at in between, if you're seeing towards right side, yes, now you have a P which is acting towards this side. See, 2P is acting in this side, and P is acting this side. So 2P and P, you'll get a P which will be acting like this. Now it will all, so this side I'm getting P, other side I'm simply applying P, because it has to be under static equilibrium. Now what is the delta for this guy? Delta for this guy will be delta 2, that is PL by A, that is 2PL, L by A. What is the cross sectional area? Simply A. What is the delta for the last one? That is delta 3 maybe, that is PL by A. So P into L by 2A. The thing is that all are actually under compression. Can you check it out? All are under compression. All the three block are under compression. Now if all the three blocks are under compression, they all will get added up. So I have not written any minus sign for them, right? Simply I have considered, because I have seen that all the three are coming with the same nature. If they are of the same nature, one can easily understand, isn't it? So if you add together 2PL by 3AI, 2PL by AI, and 3 PL by, you add it, that's all. 2PL by 3AI, 3AE plus 2PL by AE, and then what? That PL by 2AE, isn't it? How much you'll be getting it? 3 2 just 6 AE, isn't it? Then 2 दूना 4 plus 12 plus 2 3 6 3 12 3 15 4 19 19 by 16 PL, 19 by 16 PL by AE, isn't it? Under compression. Mild steel is widely used in a construction because it has what? Because it has high ductility, yes, that's correct. Because it has more strength in tension than in compression, no. the steel has the same strength either in compression and tension. This is wrong. Due to the temperature change, thermal stresses in the concrete and the steel will not develop. Yes, that is correct, because they have a same thermal coefficient, isn't it? Almost they have the same thermal coefficient. That is why it is more, useful. So these two are correct. That is only 1 and 3. Whoever have given that C option, they all are correct. Okay, next one. In the case of mild steel, which one is correct here? Percentage elongation is 20 to 25% and 20 to 25%, and percentage reduction in the cross sectional area is 60 to 70. What do you say? Which one is correct here? Which one is correct here? Which one is correct here? Yes, absolutely. That 20 to 25 is the percentage elongation. That's correct almost. And 60 to 70% of the reduction of the area. That is also correct. Basically, both are correct here, isn't it? Both are correct here. Where is the answer? That is A. Yeah, that's all. Now, stress is a, that you know already. It is a second order tensor. No need to ask. Second order tensor, isn't it? Simple question, huh? Second order tensor. Because scalar, vector, and you have a tensor. Stresses quantities, then moment of inertia, all are tensorial quantities, right? Second order tensor actually. Bar A has a diameter d and bar B has a diameter 2d. Both are of the same length and are of same material. If they are subjected to same axial load P, the ratio of extension A to extension of B, what will be that? Ratio of extension A to extension of B. That means he is asking about delta of A by delta of B, isn't it? Delta of A equals to delta of B. What will be that? Reply. Which question? Ravi Kumar. Mild steel and HY is d bar. Of course, HY is d bar. Elastic. Elastic. What do you mean by more elastic? Instead of asking, one can always find it out. How do you define elasticity? Elastic, more elastic, less elastic? You tell me. No. How you define that elastic? Whether some material are more elastic or less elastic? How you are defining it? If it is between stress and strain, stress and strain curve, you'll see that. Maybe if I'll give one, another two, which one is more elastic? Either A or B. Stress strain curve, which one is more elastic? Which one is more elastic? Now you'll get the answer. Right? So bar A has a diameter d, so deformation of the diameter d bar, that is B, has a diameter 2d. So PL by AE. Now PL by AE. So bar has a diameter d, that is PL, by AE, that is pi d square by 4, and 4 will go up, divided by PL by pi d square by 4. So actually PL by 4, that 4PL will get cancelled, pi will also get cancelled, that 4 will go up and it will remain as it is. Delta A of A by delta of B will become 4. That's all, isn't it? Consider the statement related to ductile material. Which one is correct here? Consider the statement related to ductile material. This is very important. For ductile and for brittle, both failure, please do remember. For ductile and for brittle, both failure, maybe in one liner you'll get this type of questions. Maybe for one liner 20 to 25 questions will be there, kind of one liner, not exact, kind of one liner, so one should be preparing for that also. Here, see, for the ductile material, if you see ductile, actually in a tensile test, one knows directly that under the tension, the ductile material phase at 45 degrees, isn't it? Then, okay, then under torsion, the ductile material phase under torsion, Then how the brittle fails under tension and how the brittle fails under torsion. This is the only 4 diagram you have to remember, that's all. Right? How does it fails? How does it fails? So under tension actually it fails at 45 degree, under torsion it fails at 90 degree. The brittle material, oh okay, here under tension the brittle material fails at 90 degree and under torsion it fails at 45 degree. That is the understanding, or things you have to need to remember. So failure is due to shear stress, yes, of course. Under tension it is due to the shear stress here in a ductile material that is already has been observed by us. So failure is due to the shear in a ductile material is correct. Failure is at 45 degree to the axis in tension, that is also correct. Failure occurs at 90 degree to the axis if the torsion test is done, that is also correct. So C is the correct one, which is all. Why B? B is not correct. B is not at all correct. A bar of length L and a cross-sectional area of 2A is subjected to the load of W kilonewton. The strain energy stored in the bar will be. The strain energy stored in the bar will be. What will be the strain energy stored in the bar? What is the formula for strain energy in a bar that is subjected to axial force? The bar which is subjected to axial force, what is the strain energy formula? Now area is already given. Area is already P square L by 4E. That's all. That's all. What else? What else? Now what about this one? A steel rod of circular section tapers from 2 cm diameter to 1 cm. 2 cm diameter to 1 cm over a length of 50 cm. If the modulus of elasticity of the material is 2 into 10 raised to 6 kg per centimeter square, then the increase in length under a pull of 3000 kg will be. Then the increase in length under a pull of 3000 kg will be. Which one will be the correct one here? See, if you are liking it, a kind request, please share it. Please share it. Please share it. What will be the increase in length? That is, he is asking about delta, the deformation. Now, what kind of actually structure you have? Which one will be correct? Can you tell me? Can you tell me how much time you are taking? How much time you are taking? Which one is correct? Can you please tell me? Option C is dark. Not looking? Yeah, option C is dark. I don't know whether it's correct or wrong. Just to deviate maybe your mind. Prince Prem. Legend Prince Prem. Yeah. Which one is correct? You are just writing down the formula. You are not doing it, huh? So if P force you are going to apply, what is the deformation? Deformation will be what? 4PL by pi d1 d2e, isn't it? That is the deformation you are going to get it here. So 4PL by pi d1 d2e, right? Now what is that? What is that? It is given, no? Everything is given here. So 4 into P is given 3000 C here, and L, what is that L? L is 50 centimeter. 50 centimeter divided by pi. Value of pi into d1. d1 is 1 centimeter by 2 centimeter, and E value also given, that is 2 into 10 raised to 6. Just you have to calculate. Just you need to calculate that, isn't it? 1 into 2 into 2. Am I correct here? I think it is correct. 2 to 4 will get cancelled, and it will become how it is like. Is it correct? I have written. Okay, it will become kitna 1 5, then 1 2 3 4 एक 2 3 एक 4 4 0 and divided by pi into 10 raised to 6, so it will become 4 3 4 5 6. It will become, is it visible to all of you? 0.15 by pi, that's all. Or you can write down 0.3 by 2 pi. Did you get that? Strain energy till elastic limit is known as, oh, very simple, everyone knows that. Hmm? Everyone knows that. Strain energy till elastic limit is known as, what is that strain energy till elastic limit? Strain energy till elastic limit. Strain energy one can calculate strain energy either till elastic limit or maybe till fracture. Till fracture it is known as toughness. This is till fracture, and till elastic limit is known as resilience. In a plane strain situation in xy plane, the displacement at point are given as, in a plane strain situation in xy plane, the displacement at point are given as, which one is correct here? What is the displacement, strain displacement relation equation? Do you remember that? Do you remember that? Hmm? Do you remember this one? Now he's asking in plane strain, that is gamma xy. What is that gamma xy? Gamma xy. Hmm? Del u by del y plus del v by del x, isn't it? Del v by del x. And how much you will get it? Del u by del y. What is the u? Del u by del y, you will get simply 8, है ना? 8 into 10 raised to minus 6. Then plus del v by del x. Del v by del x, if you do it here, you will get minus value. That is minus of 3 into 10 raised to minus 6. Now how much is left here? That is 5 into 10 raised to minus 6. 5 into 10 raised to minus 6. That's all. Consider the statement related to the brittle material. Failure is due to normal stress. Failure is at 90 degree to the axis in the tension. That is similar things just I told you. Failure is due to the normal stress. That is correct. Failure is at 90 degree to the axis in tension. That is also correct. Failure occurs at 45 degree axis at a torsion test. Once again, he's asking about brittle material. Oh, okay. Then fine. All are correct. Just now I told you. What about this one? For a unit weight of material gamma, for a unit weight of gamma material and a Young's modulus E, what is the deflection due to the self weight? What will be the deflection due to the self weight? What will be the deflection due to the self weight? See, you can calculate also, but I think why to calculate? One should remember these things. Not necessary that directly that formula will come. Do not think that direct formula will come. It may be asked, like value will be given and deformation may be asked, right? Sometimes they may ask. So you should be, is it B you are saying? Who is saying by B? Okay, that gamma L square by 6E. That's okay, C is correct one. The strain energy stored till fracture of material is known as, that's just now I told you, it is a toughness. Which of the component is added to killing of steel? To perform the killing of steel. Which of the component is added to perform to perform killing of steel? Do you know that? Few times I told you. Sulfur? No. Several times I told you. Yes, it is silicon. See, remember that sulfur and phosphorus actually are the kind of impurity which is actually difficult to remove 100%. Difficult to remove by 100%. Silicon we are adding to, see, you are oxidizing the steel in an initial stage, and after the oxidation of the steel, actually some of the oxygen will remains there, and it will now make the steel as a, somewhere if it is there, it will make the steel at that particular location brittle. So that excess oxygen is not at all desirable quantity for the steel. So you are adding the silicon which will remove the excess oxygen from inside the steel. That addition of the silicon to remove that excess oxygen Addition of the silicon to remove that excess oxygen is actually known as killing of steel. The steel bar AB shows varies linearly. You can just take it maybe normal variation. Normal variation you can just take it, right? Varies linearly and diameter from 25 to 50 mm in a length of 500 mm. It is held between two unyielding support at a room temperature. What is the stress induced in the bar? What is the force actually you can calculate? What is the force? What is the force induced in the bar? Can you calculate the force here? The force which is coming in the bar. This is from the temperature stress. If you are getting the tapered bar, tapered bar is actually subjected to the rise in temperature. Now what will happen? What will happen? How to perform this type of problem? The performance is very easy. Very easy. You calculate alpha LT. Calculate alpha LT. So alpha LT is nothing but your free expansion. That whole alpha LT you now subject it to the deformation. Now see, if you remember, for the normal one, for the uniform cross sectional one, what you did, you are saying that okay, there is a free expansion, that is alpha LT, then you are applying the force and you are bringing it to the same position. So alpha LT then minus PL by AE must be equal to 0. That is the concept you are utilizing for the uniform cross section. Now if it is of tapered section, you give the free expansion, no problem in that, alpha LT, but instead of the PL by AE only it will get changed. So calculate the alpha LT and minus, or I should write down equals to, instead of the PL by A, it is tapered one. If you are going to apply the force, what will be the deformation? That deformation part, if you see, that is 4 PL by pi E d1 d2, isn't it? The deformation part delta will not be same for both of them, for uniform cross section or for the change of cross section, for the tapered section, right? So now alpha LT, you calculate how much is the alpha. It is quite C. Few of the questions will be there with the moderate calculations because they are providing the virtual calculator also. They are providing for the BARC, if you see, they are providing the virtual calculator also, right? So here alpha is how much? Alpha is 12 into 10 raised to minus 6 multiplied by L is how much? L is 500. Temperature rise is how much? That is 25 degree. 25 degree then must be equal to 4P and L is 500. Actually LL will get cancelled. No need to write it down. LL will get cancelled, isn't it? So T is only 25. L here is also not going to come. So 4P divided by pi into 2 times of 10 to the power 4 into d1 d2, that is 25 and 50. 25 and 50. Did you get that? Now use that one and calculate how much P you are going to get. That small calculation, that type of calculation, small calculations can be expected. It can be expected. Can you tell me what is the answer you are getting it here? Yes, Rahul, you are saying that it is A. You are absolutely fine. You are absolutely fine, I think. Just to calculate how much you are getting it. Calculate it. I think you will be getting around 5.8, 58.6 kilonewton. See that? So that is the approach you have to make for tapered section. Now here is the question. Force P is acting on a composite bar shown in the figure. What is the force P acting on the composite bar here? How will do that? I'm not getting any comments here. Maybe am I fast or maybe you are slow? What am I? Okay, you got that A, right? Correct. Well, how you will solve this one? Similar. See, if any of the force is applied, you don't have to worry. Simply you also just apply the reaction. Suppose this side and this side, you will get the reaction. As long as they are the two different material. Yes, I don't know what is the reaction here. That reaction at A maybe and reaction at B. Simply I'm assuming, I don't know anything. Simply I'm assuming that the reaction will be in this direction. And that assumption is based, like, force is applied here, so of course the reaction will be coming to this side. But it is not mandatory. You can apply to any of the direction, and finally with the negative sign you will be able to understand. Now same thing you do it, you take it as a, at the center. If you, so first of all, RA and RB must be equal to if the P is applied here. So here one can write down, first of all, summation of all the forces in the y direction must be equal to 0. That RA and RB will be equal to P. That is the one equation first of all you will get. Then later on the compatibility can be applied, but first of all you need to draw the free body diagram. That free body diagram should draw it for the member AB. Now stand at center 1 and see at any one side. I will be seeing towards this side, it is only RA. So I'll draw that. This is a bottom one where RA is provided here. Other side I will not be worried about it. Simply I will provide RA and I will just move away. I will apply RA and I will move away. Then where? What about the other one? The BC, the copper one. For the BC, if I see BC, for the BC, RB. So stand at the central position and other side just I am seeing that RB is applied here. RB. If RB I have already seen that it is applied here, simply from other side also I will apply RB and I will just move away. So total deformation actually final is 0. There is no deformation at all. One is under elongation, one is under compression. So whatever the elongation is happening in this steel will be similar to the same as to the deformation what is happening in the copper. So I can always write it down. What I can write it down? See what I can write it down. Compatibility. This is from equilibrium equations. This is from equilibrium equation, isn't it? Equilibrium equations. Now I will be writing down compatibility conditions. Compatibility conditions. Compatibility. What is that compatibility conditions we have? That delta in steel must be equals to delta in the copper, right? Or I should say elongation in steel, contraction in copper must be equal to 0, right? So delta in steel PL by A, that's all. Now what is that? RA and this, see already free body diagram you have PL. What is the length here? L by AE. What is that? A is same. A is same. E is different. E of steel must be equal to, what is that? Another one. PL by AE, that is RC into, sorry, RB into PL. L is how much? 12 by 3 है by AE. A into E of copper, right? E of copper. And simplify this one. See, E of already given, the ES by ECU is 2. If I send that ES to other side, it will become what? ES by ECU actually will nothing 1 by 2, isn't it? It will become 1 by 2. ES by, send it to that side, EST, it will become 2 only, I think, 2. So I can write down that RA, what I can write it down? RA, LL will get cancelled, 3 will get cancelled, so AA will get cancelled. How many things will get cancelled, man? AA will get cancelled, LL will get cancelled, 3 will get cancelled. So RA by ES is equal to 2RB by ECU. Now EST, if you send it here from here to here, is it visible all of you? If you send that ES to other side, this ES also you should send it to other side, E of steel. So ES by ECU is how much? ES by ECU is nothing but 2. ES by ECU is how much? 2. So RA is nothing but 2 to the 4. 4 of RB. R is 4 of, now clear, no? All clear. Put it there, R equal to 4 times, so RB. He's asking about what? He's asking about when the force is developed in the copper. So copper has RB. So RB you want to find it out. So put R equal to 4 RB in the equation 1. So 4 RB plus RB equal to P, and RB will become how much? P by 5. P by 5. Is it under compression or tension? See, already you have taken, see, copper is under compression, that's all. Copper is under compression only now. So just for the explanation purpose only it is taking time. Otherwise, these are the one which you can solve it during the time of examination also. A copper bar of 25 cm length is fixed by means of fixed support at its end. Supports can yield by 0.01 cm. If the temperature of the bar is raised by 100 degrees centigrade, then the stress induced in the bar for alpha of C is given and E of C is also given. What will be happening here? See, same concept you can apply finally, right? He's saying that you have a support here, you have a bar here. If the support will get yielded, it means it was here, but support actually is going to yield and it will be remaining at this place. See, if you raise the temperature, that is the point of yielding. Yielding means just it is going to get displaced. It is going to get displaced. कौन सा डाया, मतलब इसमें कौन सा डाया घटाने में, कौन सा डाया घटाने में, नहीं समझ में आया, क्या पूछ रहे हो, कौन सा डाया घटाने में, या कौन सा, मतलब समझ में नहीं आ रहा क्या बोल रहे हो। So here the yielding, if it is yielding, means this is the final one, that is 0.01 centimeter, right? 0.01 centimeter taper bar value में, अच्छा अच्छा। So free expansion is actually alpha LT, and if you are going to apply the force here, what will happen, it will once again bring back to the position where it is going to get retained. So finally I can write down that alpha LT minus PL by AE is equal to 0.01. Now what is the value of alpha? You put it. Now it's a simple calculation, isn't it? So 20 into 10 raised to minus 6 into alpha L. What is the value of L? 25 centimeter into temperature rise 100, yes, minus P by A, take it as sigma, into 25 divided by A. Oh, A has gone. E, what is the value of E? That is 1 into 10 raised to 6. E is equal to 0.01. Now from here, if you calculate the value of sigma, please calculate, please do the calculation, and finally sigma you will be getting around 16 into 10 square kg per centimeter square, that small calculations can be done here, right? What about this one? An elastic metal loaded as shown in figure shows zero volume change. If Young's modulus is given, Poisson's ratio is given, then find the value of sigma. What will be the value of sigma here? So sigma value can be calculated if you know how to do the Poisson's ratio calculation. He's saying that zero volume change. What does it mean? No volume change means volumetric strain is zero. What is the volumetric strain? Sigma x plus sigma y plus sigma z divided by 3. Do you remember that? Divided by 1 minus 2 mu. Right? So actually if it is 0, then sigma x plus sigma y plus sigma z must be equal to 0. Isn't it? If sigma x plus sigma y plus sigma z must be equal to 0, here see tensile 175 plus sigma y 50, that is tensile, that is 50. Sigma z is actually compressive, so yeah, that is E. You are saying? Yeah. So here, if it is compressive, it is minus 22.5 sigma must be equal to 0, and sigma value can be calculated. How much you are getting? 225 and 25, so I think 10 you will get 10 megapascal, that's all. 10 megapascal, that's all. सही ना? 12 मतलब 225, 225, हाँ 225. Now how to solve this one? A mild steel bar of square cross section 40 by 40 mm and 400 mm long is subjected to a longitudinal tensile stress of 440 Newton per mm square and a lateral compressive stress only in one direction of 200 Newton per mm square. See, whenever this kind of problem is going to come, you draw the diagram and do not worry at all. These see, Poisson's ratio related questions will be very easy. Right, now cross section is given here, cross section of that bar is given here, then a length is given, right? It is subjected to the tensile stress. What is the tensile stress? 440 Newton per mm square is the tensile stress, and a lateral compressive only in one direction. So let it be subjected to lateral compressive one at any one direction. That is lateral compressive one at any one direction. Then he's asking what is the elongation in the bar. So it means he's asking us to find out what is the elongation. So to get the elongation, first of all, one should know what is the strain in the x direction. So if I'll consider this is my x and this is my y, x and y axis we are considering. So strain in the x direction, what will be the strain in the x direction? So strain in x direction will be simply sigma x by E. That sigma x is going to elongate this one, and sigma y, the way it is applying, the way you are applying sigma y is also going to elongate the bar in the x direction. So plus of mu times sigma y by E. Mu times sigma y by, what is value of sigma x? We have that is 440, and then you have E is nothing but 10 raised to 2 into 10 to 4, 5. Then mu is 0.3, and sigma y, that lateral compressive stress value, what is that? That is also 200 divided by E is 2 raised to 2 into 10 raised to 5. Just to calculate, just to do the calculation, you will get the strain. Achha, after calculating the strain, what will be the elongation of the bar? So delta L is asking. Delta L, what is that? Length of the bar. What is the length of the bar? Length of the bar of 400 mm long. So 400 into epsilon x, you do that, and finally you'll get 1 mm. 400 into whatever the epsilon x value you'll get the 1 mm. That's all from my side. All of you just do the preparation very, accordingly. Practice as much as problem you can. Practice as much as problems or questions you can. These are the star faculty of the Gradeup, and these are the double star of the Gradeup who got rank. There's a Gradeup Super subscription, which is quite amazing feature provided by the Gradeup. All the structured live courses and all the green card online mock test series will be together in one Gradeup Super subscription. So tomorrow, do not miss the session of SFD and BMD. Questions on SFD, BMD. And tomorrow we'll make a fire at 3 p.m. on YouTube Gradeup channel. So do not miss the session tomorrow at 3 p.m. on Gradeup YouTube channel. Thank you everyone.